In this example, we'll show how to configure a UART on the SAM D10 device and send a string through the serial port. We've connected the SAM D10 Explained Mini to the PC. Now we'll create a new project in Atmel Studio based on the Atmel Software Framework, ASF, a software library for Atmel Flash MCUs. Choose the ASF board project so that we can add drivers from ASF later. Specify the name of the project and location to which we're planning to save the project and then click OK. Then in the next window, search for SAM D10 D14 AM and choose User Board Template and click OK. Now the project is created. The SIRCOM module on the SAM D device can be configured as UART. To add drivers, we'll open the ASF wizard and search for UART. Select the SIRCOM UART driver, click on Add and then on Apply via ASF wizard. Select the driver, click on Add and click Apply. Now Studio shows the list of files that are going to be added to the project. Click OK. Once the driver is added, build the project so that the device-dependent header files will appear in the project dependencies. This will help us to take the pin definitions from the device header file. After building the project, we'll try to find out whether there are any application notes available for the SIRCOM. From the web page, we can locate an application note for the SIRCOM UART. In this application note, there are some examples for the SIRCOM UART driver. We'll follow the basic steps in the basic example given here. It shows the code which can be used in our project. So we've just copied the code to our project. Since the given example is for Explain Pro boards, we might need to change the multiplexer settings, pad configuration, and select the SIRCOM module to be used. From the user guide for the SAM D10 Explained Mini, we can see that the kit offers a virtual COM port. Now we should identify which pins of the SAM D10 device can be used to send data via the virtual COM port. In the code, we'll configure PA10 and PA11 as shown in this section of the user guide. From the datasheet, we'll try to find out which SIRCOM module should be used if we want to utilize the virtual COM port on the Explained Mini kit. As we can see in the table, we can use function C for PA10 and PA11. Now we are going to change the multiplexer settings. Let's find out whether the UART H header file shows any predefined multiplexer settings. From the drop-down box on the left, we can look for the functions, enumerated type, etc. We'll select the enumerated type for the UART multiplexer settings and open its definition. Here we have a list of possible MUX settings. From the datasheet in the section that describes SIRCOM UART, we'll try to find out how to select the TX and RX pin for the SIRCOM. This will help us to use one of the predefined multiplexer settings from the UART H header file. Earlier, we've noted from the section I/O multiplexing and considerations that we are going to use the SIRCOM 0 pad 2 as RX and SIRCOM pad 3 as TX. In this case, RXPO should be 3 and TXPO should be 1. In the UART H header file, we can see a multiplexer setting that uses RXPO as 3 and TXPO as 1. So we'll copy these MUX settings to the code. Since we need just the TX and RX pins, we can remove pad 0 and pad 1 from the configuration. We'll use pad 2 and pad 3 for UART. As we've seen earlier in the datasheet, we're going to use peripheral function C for PA10 and PA11. In the register description, we can find that there are peripheral multiplexing registers which need to be configured to select a peripheral function for a port pin. For Cortex-M devices, the peripheral multiplexing definitions are available in a header file in the ASF structure. You can find the file in ASF, SAM 0, utils, semsys, SAMD, include, PIO. We'll open the file for SAM D10 D14 AM and search for SIRCOM. Here we can see the port definitions for SIRCOM 0. From here we'll find out the pinMUX setting to enable function C for PA10 and copy it to the code. Also for PA11, we'll take the required pinMUX settings to select function C. Now, let's change the SIRCOM module to SIRCOM 0. We can just go back to the application note from SIRCOM UART and copy the required code to the main function. Now we have the complete code in the main C file. Build the project by pressing F7. Now the question is how to receive the characters sent from the SAM D10 explained mini kit onto the PC. We know that the kit has a virtual COM port. Let's open the device manager and look for the virtual COM port. Yes, the virtual COM port on our SAM D10 Explain Pro is listed there. Open a terminal application to receive data from the MEDBG virtual COM port. To load the hex file into the SAM D10 device, select the programming tool and click on the icon Start Without Debugging. Once the code is loaded, we can see the characters received in the terminal application.